Hello and welcome to the live session by Infinity Learn by Sri Chaitanya. I am Misbah, your maths educator, and in this session we are going to talk about the Basic Proportionality Theorem or the Thale's Theorem, and we'll be doing some questions on the basis of the BPT, which we call in short, or the Thale's Theorem. So let's start with it. So the theorem over here is, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. So what does it mean? If you have got a triangle over here, suppose I am making a triangle, suppose this is ABC, and in this triangle, suppose through this base BC, we are making a line parallel to it to intersect AB at D, and AC at E. Suppose this is the situation over here, then AB and AC are divided in the same ratio. It means if it is given that DE is parallel to BC, then we can conclude that, then it can be concluded that AD by DB, we can say that AD by DB, that is equal to AE by AC. So that is the basic proportionality theorem over here. If a line is drawn parallel to one side of a triangle to intersect the other two sides at distinct points D and E over here, the other two sides are divided in the same ratio, that is AD by DB is equal to AE by EC. So this is the basic proportionality theorem, which we call in short as BPT or the Thale's theorem. I hope it is clear. So suppose a very basic question we can do on the basis of this concept. So suppose it is given that this situation is given to you. Suppose this thing is 2 units over here and suppose this thing is of 3 units over here, right? And we have to find, suppose this thing is 5 units and we have to find the value of x over here. A simple example. It is given over here that DE is parallel to BC, AD is 2 units, DB is 3 units, AE is 5 units and EC is x units. We have to find the value of x. So according to the basic proportionality theorem, AD by DB is equal to AE by EC, or we can say over here that 2 by 3 that is equal to 5 by x. So it is a simple equation, guys. So from here x will be equal to 5 3s are 15 by 2 units. Okay, so no centimeter or meter is there, so 15 by 2 units is the answer. I hope the question is clear, a very basic question on the basis of the basic proportionality theorem, or if you hear the name Thale's theorem, it is the same thing, or in short we call it BPT as well. Now there are some corollaries of the basic proportionality theorem. Corollary means on the basis of a theorem there are small results which are used many a times in questions as well directly. So let us see the corollaries of the basic proportionality theorem. So first thing is, suppose I've got a triangle over here and suppose this is A, B and C, and it is given over here that DE is parallel to BC. DE is parallel to BC. This thing is given. So the BPT is what, guys? The basic proportionality theorem which we have done in the previous slide, that is AD by DB, that is AD by DB is equal to AE by EC. I hope this thing is clear up till here. Now suppose in this result only, can I add 1 on both the sides of this equation, guys? Can I add 1 on both the sides of this equation? So this is AE by EC plus 1 over here. Now can I take the LCM of the denominator? So I'll get AD plus DB by DB over here, and that is equal to AE plus EC by EC over here. I hope this thing is clear. Now what is AD plus DB, guys? That is equal to AB or not, tell me. So that is AB. So AB by DB over here. Now what is AE plus EC? That is AC over here. So AC by EC. So you see, this is a corollary of the basic proportionality theorem which you can remember directly. That if you have been given that DE is parallel to BC, you can directly say that AB by DB is also equal to AC by EC. So this is a corollary of the basic proportionality theorem, or you can take its opposite as well. If you take the inverse of it, can I not say over here, or we can say that dB by AB, we can say that dB by AB is also equal to EC by AC. EC by AC. So that is also true over here. So if you have got a triangle ABC in which DE is parallel to BC, then the first result is the basic proportionality theorem, which is AD by DB is equal to AE by EC, the first thing, or you can say AB by DB is equal to AC by EC, or you can take the opposite of that, you can say DB by AB is equal to EC by AC. So this is the corollary of the basic proportionality theorem. Now there is one more thing, one more type of corollary can be there. Let's move on to the next thing. Suppose the same situation I am taking over here. Suppose this is ABC and we are making a line segment DE parallel to BC to intersect AB at D and AC at E over here. So the BPT is what, guys? The basic proportionality theorem, that is AD by DB, that is equal to AE by EC over here, correct? AE by EC over here. Now can I take the opposite of it? So can I not take DB by AD, that is equal to EC by inverse of that basically. So I can take DB by AD, that is EC by AE over here. I hope this thing is clear. Now can I add 1 on both the sides of this equation? So I will get DB by AD plus 1, that is equal to EC by AE plus 1. I can add 1 on both the sides of this equation. Now can I take LCM and simplify? So that will give us DB plus AD by AD, that is equal to EC plus AE by AE upon AE over here. So basically we are going to get DB plus AD. So what is DB plus AD? That is AB over here. So AB by AD we are getting, AB by AD, and that is equal to EC plus AE. EC plus AE, that is nothing but AC by AE over here. So guys, this is also a corollary of the basic proportionality theorem, that if you have got a triangle ABC and DE is parallel to BC, where D is a point on AB and E is a point on AC, so you can say over here that AB by AD is equal to AC by AE. That can also be said, or you can take its inverse as well. You can basically say over here that AD by AB, that is equal to AE by AC using the basic proportionality theorem. This is a corollary of the basic proportionality theorem. So these are the corollaries. You can say this one and the previous two, they are the corollaries, because if you do the inverse, you don't take it a different corollary. I hope you understand that. So this is the first corollary on the basic proportionality theorem. This one is the second corollary on the basis of the basic proportionality theorem, because I am not considering the inverse cases as two different corollaries. I hope you understand that, but sometimes you might see that they are two different corollaries, so you don't have to get confused in those things. I hope it is clear to every student in this session. Now, there is one thing, converse of the basic proportionality theorem or the Thale's theorem, which we call. So converse means the opposite, like you must have studied the Pythagoras theorem, the converse of the Pythagoras theorem. The midpoint theorem in grade 9 you have studied, and the converse of the midpoint theorem. In the same manner, converse of BPT is also there. What is that, guys? If you have got a triangle ABC and there is a line segment DE which is intersecting AB at D and AB at D and AC at E. And if it is given that DE is dividing AB and AC in the same ratio, if it is given that AD by DB is equal to AE by EC, if this thing is given to you already, then you can conclude that DE is parallel to BC. Can we say that, guys? If it is already given to you that AD by DB is equal to AE by EC, you can conclude that DE is parallel to BC. This is the converse of the midpoint theorem, and many a times it will be used in questions. I hope it is clear to you. Now let's do some questions on the basis of the midpoint theorem. So let's do this one. It is given in this figure that you have to find the value of x which will make DE parallel to AB. The value of x which will make DE parallel to AB over here. Can you try doing this question, guys? So basically we have studied the midpoint theorem. If you want DE to be parallel to AB over here, obviously we have to take AE by EC to be equal to BD by DC, guys. AE by EC to be equal to BD by DC we have to take or not, tell me. I hope this thing is clear. So can I not write over here, in place of AE, can I write 3x plus 19 from the figure itself divided by, in place of EC, can I write x plus 3 over here, guys? And that will be equal to 3x plus 4 by x. 3x plus 4 by x over here. I hope this thing is clear up till here. So we can just do cross multiplication and simplify and solve this equation. So if you cross multiply, you'll get 3x square plus 19x, and that is equal to what, guys? If you cross multiply over here, if you simplify, you'll get 3x square plus 4x plus 9x, that is 13x over here. So 13x plus 4 3s are 12. So you see this will be cancelled out, guys. This will be cancelled out. If you take it on the other side of the equation, 19x minus 13x, that is 6x, and that is equal to 12. So can I not say that x is equal to 2 is the answer? I hope this thing is clear. So it is a direct question on the basis of the basic proportionality theorem. I hope this thing is clear to every student watching this video. So let's move on, guys. So how can we do this type of question over here, guys? It is given over here that DE is parallel to AC. DE is parallel to AC is given to us. So let us make it like this if we want. You know that this is the sign of parallel lines. And it is also given that DF is parallel to AE. DF is parallel to AE. So we have to prove over here that FE upon BF, that is equal to EC upon BE over here. I hope this thing is clear. Now you see, this is a very simple question on the basis of the basic proportionality theorem. It might look that it is complex, but it is very simple. Because if I take the first case, you see DE is parallel to AC is given to us. DE is parallel to AC is given. So can I say that BD by DA, that is equal to BE by EC using the basic proportionality theorem? Can I say that? Suppose this is the first equation. Can I not say that? In the same manner, it is given that DF is parallel to AE. Just see the question, guys. DF is parallel to AE. This thing is given to us in the question itself. So you see, if DF is parallel to AE, can I say BD by DA is equal to BF upon FE using the basic proportionality theorem? BD by DA, that will be equal to BF upon FE over here, guys. BF upon FE using the basic proportionality theorem. Can I say that this is the second equation over here? So you can see over here that the left hand side of both of these two equations are equal. So can I not say that the right hand sides will also be equal? So over here, can I not say that BE by EC, BE by EC, that is equal to BF upon FE? But actually that we don't need to prove in the question. It is basically the inverse of that, right? So can I not take over here, I can easily write that EC by BE, that is equal to FE by BF, FE by BF over here. I can easily say that. I hope this thing is clear to every student in this session. It's a direct question on the basis of the basic proportionality theorem. I hope it is clear, guys. So let's do one more question on the basis of the basic proportionality theorem over here. So in this question, it is given that you see, this is a point O inside the triangle OBC, and it is joined to the vertices of this triangle from a point D DE is parallel to AB. So basically it is given that DE is parallel to AB. It is given in the question. And from point E, EF is parallel to BC. You see, EF is parallel to BC is also given to us. This thing is given. We have to prove that DF is parallel to AC. We have to prove over here that DF is parallel to AC. So how can we do this question, guys? We have to prove DF is parallel to AC. So it is pretty simple over here. Let's do that, guys. So basically, if it is given that DE is parallel to AB, what we can do? If it is given to you already that DE is parallel to AB over here, can I not say using the basic proportionality theorem, OE by EB that is equal to OD by DA using the basic proportionality theorem? Suppose this is the first equation over here. Now it is given over here that EF is parallel to BC. So can I say using the basic proportionality theorem, can I say OE by EB is equal to OF by FC. So this is happening using the basic proportionality theorem. So you see the left hand side of these two equations, they are equal. So can I not say that their right hand sides, this is the second equation, can I not say that their right hand sides will be equal as well? So can I say over here that OD by DA that is equal to OF by FC, guys? Can I not say easily over here? So basically we have proved OD by DA is equal to OF by FC. So if that is the case, can I not say over here that DF will be parallel to AC? And what is the reason? The reason is not the basic proportionality theorem. You have to see that over here. So can I not say over here that DF is parallel to AC over here using the converse of BPT? This is not BPT over here. This is the converse of the basic proportionality theorem. I hope this thing is clear to every student in this session, guys. I hope this is a very simple question. Okay, now one more simple question I am taking over here. Suppose over here itself, and that is the midpoint theorem, right? The line segment joining the midpoints of two sides of a triangle is parallel to the third side and is equal to half of it. That you cannot prove. But the line segment joining the midpoints of two sides of a triangle is parallel to the third side. That can be proved in one or two lines using the basic proportionality theorem. So suppose I am taking over here only, and it can be done using converse of the basic proportionality theorem. Therefore, I am taking it over here. So suppose it is given to you, there is a triangle, simple example I am taking, ABC. So you are taking the midpoints of two sides of the triangle and you are joining them. Suppose DE. So this is equal to this and this is equal to this. The line segment joining the midpoints of two sides of a triangle is parallel to the third side. We have to prove DE is parallel to BC. We cannot prove using the basic proportionality theorem that DE is equal to half of BC, but parallel we can easily prove. You see over here, it is given that D is the midpoint. So can I not say that AD is equal to DB over here? Can I easily say that? So from here, can I not say that AD by DB is equal to 1 only? Do you agree with me? Suppose this is the first equation. In the same manner, E is the midpoint of AC. So can I not say that AE is equal to EC over here? I'm sorry. First we need to show that. We can say that AE is equal to EC over here because E is the midpoint of AC over here. So can I not say that AE by EC is equal to 1? AE by EC is equal to 1. The second equation over here. So can I not say that AD by DB is equal to AE by EC over here? We can easily say that, guys. We can easily say that AD by DB is equal to AE by EC. Now can I use the converse of the basic proportionality theorem? We have already proved AD by DB is equal to AE by EC. So we can easily say that therefore DE is parallel to BC. DE is parallel to BC, and that is not the basic proportionality theorem. That is the converse of the basic proportionality theorem. That is the opposite of the basic proportionality theorem. I hope this thing is clear to every student up till here. So guys, that's all we needed to do in this session. Please watch the recording. In case of any doubt, please put in the comment after this class, And don't forget to like, share and subscribe to the Infinity Learn Class 9 and 10 YouTube channel. Bye bye guys. Take care everybody.